In module 1, we have discussed about the concept of statistical model and how they are designed. In this module, we will discuss about two very important concepts related to statistical modeling. First, random variable, and second, probability distributions. We will keep it short and simple. We will try to avoid any complex mathematics. Those who have not watched the module 1 are requested to watch it. I have given the link in the description and also at the end of this video. Let's start. We know that statistical model defines the functional relationship between two variables. So first of all, what we will do is that we will try to define the functional relationship between two variables y and x. Y is the dependent variable and x is the independent variable. That we have discussed in module 1, right? And this particular functional form gives a outcome, okay? And the particular outcomes can be of two types. Either it can be deterministic or it can be stochastic. Deterministic outcomes are those outcomes which we are very sure of. For example, age of a particular person. Given the data points, we can very well and with certainty tell the age of a person. Stochastic outcome are those outcomes those have a probability value associated with the outcome. For example, rainfall. Rainfall data, if we are planning to have, we can only tell whether it will rain or not if we have a certain probability associated with that. Outcome can also be defined as discrete or continuous. The outcomes which are finite in nature and are countable are discrete outcomes, and the continuous outcomes are those outcomes which have infinite points between 2 points. For example, temperature. Now if we take two data points, okay, suppose this is 7 degree and this is 8 degree, okay. Now there can be infinite possibilities between these two data points, okay. Hence the outcome is continuous in nature. Now whenever we have done a statistical model, we have told that there is a difference between the actual value and the predicted value, and that is known as error. Now let us first understand what are the sources of the error. The first source of error is the model itself. As we have discussed in module 1, we are not sure of the functional form, but we try to assume some functional form and we try to fit the data in that functional form. So if the model is imperfect, we can have error. Error means the predicted value and the actual value will be very, very different. So we will try to have a model where this error is minimum. The second source of error can be measurement error. It is the instrument which we are using for certain measurement, it's faulty, and in that case the error will be of measurement error but not modeling error. Our main focus will be on this measurement error and modeling error, but we will try to form models where we can minimize the modeling error. Now why we are so much interested in errors? Because what we do basically is that we try to minimize the loss function, okay. We try to minimize the error, because if we have minimum error, if a model can give minimum error, then only our model can be taken as a very good model or a representation of the actual data set, right? So what we do is that the errors are modeled with the help of probability function. We define a probability function so that this particular error is, all the statistical modeling is focused on this functional probability form which are designed to minimize the error. And depending on the data type, this probability function is either probability mass function or probability density function. Now coming to the part of random experiment, we will try to define random experiment as an experiment which is stochastic or random in nature, and it is an experiment because the outcomes are not really known. Probability is used to assign real value to these particular outcomes, and the random variables are the functional representation of the outcome of the random experiment. That means there is an outcome. Okay, so there is an outcome. This outcome is assigned a real value, and this real value is assigned with the help of probability. Then what is random variable? Random variable is the functional representation of the outcome. Okay, have you understood it? There is an outcome, there is a real value associated given to the outcome with the help of probability, and random variable is the functional representation of that outcome. Okay, now if we are planning to understand random experiment, we need to also understand certain key points in random experiment. One is sample space. Sample space is the set of collection of all possible outcomes. Suppose we are tossing two coins. What is the outcome? Either it can be two head, a head and a tail, a head, and two tails. So all the possible outcomes are included in this set, which is a sample space. Suppose if we take a particular outcome of interest, suppose two head or two tail. So these are the subset of sample space, which is known as event. So event is a subset of the sample space. Sample space includes all the possible outcome of a random experiment. Clear? Now, mutually exclusive. Mutually exclusive events are those events if a particular event occurs, then other cannot occur. That means only one can occur at a time. If we toss a coin, either head or tail will come. Both will not come together. Right? Independent. That means the outcome of an experiment does not influence the outcome of the other experiment. If a head comes in the first toss, it will not influence the outcome of the second toss. Right? Equally likely. Equally likely are those things. Equally likely are unbiased outcome. That means all the outcomes have an equal probability of occurrence. I mean, a head, a head tail, tail head, and a tail tail. All the outcomes has an equal probability. Then only we will tell the event to be equally likely. These are important things which we should understand in order to have a clear-cut understanding of the probability distributions and random variable in statistical modeling. Probability density function, probability mass functions are basically the representation of the data. We have binomial distributions, we have normal distributions, we have Poisson distribution. These are all probability distributions. We are not going into the details of those distributions as of now. We will continue those things in the next modules. So there is one more thing that we should also understand, is that the probability is also like defined as an frequency. It is very simple representation, the total number of outcomes of an experiment and the number of times that event we are interested in is coming is given by this formula, the probability, when we take the frequency approach of probability distribution. Okay, in the next module what we will do is that we will try to understand the mechanics of statistical modeling, which means that what are the basic things that needs to be taken care of when we do modeling, and we will discuss about ANOVA, we will discuss about R square, we will discuss about p-value, okay, we will discuss about inferential statistics and hypothesis testing and all those things, and we will also try to cover certain areas of testing, suppose t-test, f-test, z-test, and how come those things are used in the statistical modeling part. Till then, goodbye.